Hi, I am Kalyan Reddy Daida and I will be your instructor in this course Azure Kubernetes Service with AGIC Ingress 30 real world demos. So here we are going to implement or install the application gateway ingress controller on our Azure Kubernetes Service AKS cluster, and we are going to implement 30 real world AGIC Ingress demos. So we are going to start with installing AGIC controller as a AKS add-on on our Azure Kubernetes Service cluster, and after that we will learn Ingress basics using Ingress default backend demo and also Ingress HTTP paths and rules demo. So once we learn the basics, we'll go ahead and then implement the Ingress URL routing, which is nothing but on application gateway. We are going to call it as path-based routing. So using Ingress service declaratively, we are going to define a Ingress service object with URL routing, and that is going to get created as path-based routing in our application gateway. So we are going to implement that with 3 sample applications. After that, we'll go ahead and also implement Ingress backend path prefix and Ingress backend hostname related demos. And once we complete those things, we'll also learn and implement Ingress cookie based affinity. Here also we will implement 2 demos related to cookie based affinity, and then we'll move on to implementing Ingress override front-end port. So how to override the front-end port on application gateway? By defining a annotation in Ingress service declaratively, we are going to learn as part of that demo. And we are also going to create a rewrite rule sets on application gateway and reference them in Ingress service and implement it and understand more in detail about rewrite rules on application gateway using Ingress service. After that, we are going to implement 5 demos for health probes. So this is very important concept on application gateway, and we are going to have 5 demos in detail. And how we are going to implement it is, we are going to implement it in a priority order. So from low priority to high priority, how it is going to be defined and how these health probes helps us. And if example, like if readiness probe and liveness probe both are defined, which takes the priority in creating a health probe on application gateway, we are going to discuss and implement it. In the same way, if Ingress health probe annotations were defined in Ingress service and readiness and liveness probes are defined in your deployment, Kubernetes deployment, which takes the priority and using which data health probe is created in application gateway, we are going to review and implement. So we are going to have detailed 5 demos for health probes concept, and it is a very important concept for the health of our applications running on Azure Kubernetes service, which is fronted with application gateway as a load balancer. So we have discussed it in very detail. From there, we'll move on and then implement delegating a DNS domain from AWS Route 53 to Azure DNS zones. So the upcoming demos after this demo is like we need to have a dedicated domain name so that we'll be able to implement some advanced demos using external DNS. So for that purpose, we are going to implement delegate DNS domain. So you can delegate a domain from any of the domain registers like Namecheap or even AWS Route 53. Here we have took AWS Route 53 as the example. And from there, we'll go ahead and then install external DNS controller on our Azure Kubernetes service cluster. And once we install the external DNS controller, we'll move on and implement a basic external DNS related demo. So in Ingress, we are going to define that using spec.rules.host, and with that, we are going to implement that demo. And once that is done, we are going to implement Ingress domain name routing demo. So with this, with 3 different applications with 3 different DNS names, right? So we are going to route the traffic to our backend applications. So that with Ingress domain name routing in combination with external DNS and Azure DNS zones, we are going to implement that with AGIC Ingress controller. And once that is completed, we are going to implement Ingress TLS SSL and Ingress TLS SSL Redirect. So here we are going to enable SSL for our application SSL certificate and key to our application using Ingress TLS concept. And we are also going to enable HTTP to HTTPS redirect as part of this demo. And from there, we'll move on and then also implement one more demo wherein we already have our Ingress SSL certificates in application gateway, and then how to reference them in our Ingress service, right? So that demo also we are going to implement. After that, with two demos, we are going to focus on implementing a end-to-end SSL scenario. There, first, as part of demo 20, we'll build the backend SSL application and then test it. And after that, in demo 21, we'll focus on implementing frontend plus backend SSL and test it end to end. So that we are going to do. After that, we'll focus on implementing Ingress SSL with Cert-manager and LetsEncrypt. So here we are going to generate SSL certificates which are production grade certificates using LetsEncrypt. And from LetsEncrypt to LetsEncrypt, we are going to submit the CSR, SSL certificate CSR using Cert-manager. So all these things are going to happen automatically. So provisioning of SSL certificates on our AKS cluster and for our application gateway using Cert-manager and LetsEncrypt, we are going to do that. And these certificates are production grade SSL certificates. And after that, we will implement two demos for web application firewall. So how we are going to use Ingress with web application firewall on Azure, we are going to do that. And we are going to have two demos. One is with WAF custom policy and other is with default OWASP policies of WAF. So once WAF is completed, we'll focus on implementing Azure Application Gateway Private IP. So for internal applications, if you want to access your applications internally, and then it should be fronted by application gateway, and for that purpose, we will associate a private IP to our application gateway and use it in the Ingress service. So that demo we are going to implement. After that, we will implement multiple Ingress controllers demo. So here already on our AKS cluster, we have the AGIC Ingress controller up and running. In addition to that, we will also install the Kubernetes Nginx Ingress controller, and we are going to deploy two applications as part of the demo, and one application will be associated to Nginx controller and the other application will be associated to AGIC controller. So how we are going to do that? With the concept called Ingress class names, we are going to implement that as part of demo 26. And from there, we'll go ahead and then implement or install AGIC controller using Helm CLI. So far, whatever we have implemented all these demos, the AKS cluster with application gateway Ingress controller, we have installed as an add-on to AKS cluster. But from here on, we'll create a new environment, and in that new environment, we'll create a AKS cluster and we'll create a application gateway, and AGIC Ingress controller, we are going to install it using Helm CLI with Helm charts. And this is very helpful if you want to customize your application gateway Ingress controller. So how we need to customize it? Example, if you take demo 28, right? So if you want to use your application gateway to share with other Azure resources and also with Azure Kubernetes service in combination, then you need to enable shared equal to true in your AGIC controller. And that one, when you are using Azure Kubernetes service with application gateway Ingress controller as AKS add-on, it is not possible. It is possible only when you install your AGIC Ingress controller using Helm charts on your AKS cluster. So that is one thing. In addition to that, there is one more, which is like AGIC watch specified namespaces only. So AKS add-on, when you add application gateway ingress controller as AKS add-on, you don't have an option to customize and tell your AGIC that only monitor specific namespaces in your AKS cluster to sync the ingress related changes to the application gateway. So that option is not available when you use AKS add-on. But when you use AGIC with Helm charts, right? AGIC installation using Helm charts, so you can watch specified namespaces. Example, you have production, staging, dev, and then QA namespaces in your AKS cluster, and here ingress service related changes should be populated to application gateway only for production namespace. If that is the case, then you can provide that setting in your Helm config and then upgrade your Helm release, and accordingly it is going to monitor the changes only on the production namespace. So that's very, very advanced concept, and it is very important concept to be known. So that's the reason AGIC install using Helm CLI and share application gateway with other Azure resources, and AGIC watch specified namespaces only. So these three advanced demos also we have covered as part of this course. In addition, right, so these demos on Udemy are configured in a incremental order. So you can see demo 1, demo 2, demo 3, demo 4 in such a way that simple to complex demos. So we will start with simple demos and progress to complex ones. By the time we reach 27, 28, 29, so these are complex implementations which we have simplified with step-by-step documentation and with architectural diagrams, but we have arranged the content in such a way that we will start with simple demos and slowly we will progress on implementing complex things by learning step by step. And for every demo, we are going to have a GitHub step-by-step documentation. And here are the GitHub repository URLs and course presentation related URLs which you can use and reference them. And we have 100+ presentation slides outlining various AGIC architectural diagrams which we have implemented as part of this course. So this completes the introductory part of this course, and most of my students request for detailed introduction, which means what all architectures we are going to discuss and how the architectures are going to look like and what we are going to build as part of this course. So for them, I'm going to move on and then discuss all these 29 demos in the introductory section itself in a little detail. So it might take little bit of time. So if you are satisfied here, you can skip this lecture and move on to the course for implementing the demos. Now we'll move on and understand visually what we are going to implement as part of this course. So we are going to start with demo 1, wherein we are going to create a virtual network, subnet for application gateway and subnet for AKS cluster, and we are going to create AKS cluster using Azure command line CLI, and with a single command we will be able to create AKS cluster, application gateway, and also add AGIC Ingress controller as AKS add-on. Then we will also learn about what happens, right? What this AGIC Ingress controller does in a detailed manner as part of demo 01. And once that is completed, we'll move on and implement in demo 02 Ingress default backend. So with Ingress default backend, what happens in a visual manner, we are going to discuss in detail and implement it. After that, we'll also go ahead and then implement Ingress HTTP rules and paths. So if you see the difference between default backend and HTTP rules and paths, you can see path-based routing is enabled on application gateway when we have used HTTP rules and paths. So you can see /app1 is added here, right? But in default backend, you don't see that. So all those things we are going to discuss in detail and implement in these two demos. So from there, we'll move on to demo 04, where we are going to use 3 applications in our Ingress service, and when this Ingress service is deployed, on application gateway, a path-based routing for /app1/app2 and for root context are default backend. So that is going to get deployed and implemented. So we are going to implement a path-based routing with 3 applications as part of this demo. And from there, we'll move on and implement Ingress backend path prefix. So this is another important demo wherein from the internet you are coming with one URI, and in the backend your application is hosted on different URI. So how that rewrite happens, how the backend path prefix rewrite happens, all that logic is defined in application gateway. So that one you are going to define in your Ingress service declaratively, and after declaring and deploying it, all these things will be taken care automatically. So how we are going to define it declaratively, we are going to discuss in detail and implement it as part of this demo. And after that, we'll move on and also implement demo 06, which is backend host name. So from the internet, you are coming with one host name, and to the backend, if you want to provide a different host name, then how you are going to configure it, you are going to do as a learn as part of this demo. So you are going to define this annotation in the Ingress service and implement it. After that, we'll go ahead and also implement cookie-based affinity. So with cookie-based affinity is just an annotation section change in your Ingress service. When you enable this, affinity will be enabled for your requests coming to the application, which means on the browser, whenever you access your application, your request will be persisted to that respective pod. And here with cookie-based affinity, we are going to have 2 demos here. And in addition to this demo, we are also going to have cookie-based affinity distinct name related demo. So these 2 demos we are going to implement, and after that we'll go ahead and also implement Ingress override front-end port. So your application gateway front-end port can be overridden by defining an annotation in Ingress service with desired port number. So that we are going to do as part of this demo. After that, we are going to define a rewrite rule set in our application gateway and associate that to our Ingress service using an annotation, so that what all rewrite rules defined in this rewrite rule set will be applied to our application. So that we are going to implement as part of demo 09. From there, we'll go ahead and implement health probe related 5 demos. So as I said earlier also, that health probes are very important, and to define them, we need to understand their priority order. So we'll discuss their priority order high to low and implement them. So we'll start with implementing Ingress with default backend. It uses a default HTTP probe. So we are going to see how it is going to work, and from there we'll move on and implement Ingress HTTP path-based routing in Ingress, which creates a custom HTTP probe for us, and that we are going to review. After that, we'll move on and implement a readiness probe for our Kubernetes deployment, and which will create a custom HTTP probe for us, which we are going to review on the application gateway. And once that is completed, we'll go to the next demo, which is Liveness probe. So when Liveness probe is defined in your Kubernetes deployment, it creates a custom HTTP probe in your application gateway. So that we are going to review in detail. And after that, we'll also go to use case 3 for demo 11, which is when Readiness probe and Liveness probe are defined, which one takes the priority to create a custom HTTP probe in application gateway. So the priority which takes is Readiness probe will have the highest priority. So whatever the content present in Readiness probe, those will be used inside this custom HTTP probe. So all these things are like declaratively you are defining in your deployment for these Readiness and Liveness probes, and on the application gateway custom HTTP probe automatically gets created because AGIC Ingress controller takes care of syncing those changes to application gateway. So all those things we are going to practically implement it. Finally, we are going to define in our Ingress service AGIC health probe annotations, and which creates a custom HTTP probe, which we are going to go to application gateway and then review it. So once these health probe related demos are completed, we are going to delegate the domain to AzureDNS. from any of the domain register. I have used AWS Route 53, but you can use any desired one where your domain is present, like Namecheap or GoDaddy. And after that, we will install the external DNS. During the process, we are going to learn about how the external DNS pod inside the AKS cluster is able to access and add, delete and update the records in DNS zones using managed service identity. We are going to discuss in detail and implement it. After that, we'll go ahead and then implement a simple external DNS basic demo, wherein in the Ingress service, we are going to use specs.rules.host. From there, we'll move on and then implement domain name based routing. So here we have three applications, app1, app2 and app3. And when we access eapp1.kubeoncloud.com, the request should go to app1. And eapp2.kubeoncloud.com, request should go to app2. And eapp3.kubeoncloud.com, it should go to app3. And these related, for these three applications, whatever the ingress related spec.rules.host we define, so using that, automatically these DNS should be registered in DNS zone, and in addition to that, their equivalent listener should be created in application gateway. So all these things happens automatically by just deploying a simple ingress service by defining spec.rules.host. So this whole demo we are going to see practically. From there, we'll move on and then implement Ingress SSL TLS, right? So Ingress TLS is one important concept from Ingress service perspective. So we are going to create a SSL certificate and SSL key, and using those two things, we are going to create a Kubernetes secret and reference that Kubernetes secret in this Ingress service. And when we deploy this Ingress service, this SSL certificate will be automatically uploaded to application gateway by AGIC Ingress controller. And we are going to see this demo practically. At that point of time, whenever we access via browser with HTTPS URL, so our application will be accessible on SSL. After that, we are also going to implement SSL TLS redirect, which means HTTP to HTTPS automatic redirection. So we can access a HTTP URL and it will automatically redirect to HTTPS. So for that, we are going to add the following annotation to our Ingress service. From there, we'll move on to implementing Ingress SSL plus SSL upload to app gateway. So this demo is primarily focusing on, already we are having some SSL certificates in application gateway and we want to reference them for our application using Ingress service. So how we are going to do that? We are going to create a SSL certificate and SSL key and convert that to SSL PFX file and upload that PFX file to our application gateway, and that whatever the application gateway certificate is there, that we are going to reference in our Ingress service using app gateway SSL certificate annotation. So this we are going to implement it, and then we'll move on to implementing a end-to-end SSL. For that purpose, first we will implement a backend SSL application and access it via browser with a simple load balancer and test it. So there we will create a SSL certificate and SSL key for backend application and create a backend Kubernetes secret and associate that in our Kubernetes deployment. And after that, we are going to go ahead and then implement a end-to-end SSL as part of demo 21. So here for backend application SSL, you can see it here, and for front-end application is nothing but front-end SSL also we are going to define here, and that front-end KITS secret is referenced in Ingress service, which means when this Ingress service is deployed, those certificates will get automatically uploaded to application gateway. And in addition to that, when we access it via browser, we can see from end to end, from the user to the backend application, everything is going to be HTTPS. So this we are going to implement. After that, we'll go ahead and then implement Ingress SSL with LetsEncrypt, right, and Cert-manager. So here we are going to install the Cert-manager, and using Cert-manager, we are going to request LetsEncrypt for a production grade SSL certificates, and once those come in, right, So those will get uploaded automatically to application gateway, and when we access via browser, both applications will have a production grade SSL certificates. This is going to be a very good implementation and a complex implementation which we are going to discuss in detail in a step-by-step manner and implement it. After this, we'll go ahead and then enable WAF on our application gateway and also enable default OWASP policies and implement this demo. And once this is completed, we'll also define a custom WAF policy and reference that custom WAF policy in our Ingress service. When that is applied, right, which means our application will have this WAF custom policy applied, and we are going to test it via browser and then see that those requests which are related to attacking our applications are blocked by WAF or not. We are going to test it. And after that, we will associate a private IP to our application gateway, and that private IP we are going to reference in our Ingress service and deploy our Ingress service, right? So using this annotation, right? Reference it, and then after that deploy the Ingress service. And to access your application, now this application is accessible internal to your network. So how to access it? We are going to deploy a simple curl pod and access it using private IP. After that, we are going to deploy multiple Ingress controllers. So on our AKS cluster, already we have a AGIC Ingress controller. We are also going to have Nginx Ingress controller deployed on our AKS cluster, and we are going to associate app1 application with Nginx Ingress controller using Ingress class name, and app2 application to AGIC Ingress controller using Ingress class name. And accordingly, when we deploy, so the request coming to this app1 is via Nginx Ingress controller, and for app2 it is directly from application gateway to pod. So you will very clearly see the latency, how this Nginx Ingress controller adds, and how the benefits we get with AGIC Ingress controller from picture itself, and when we are implementing also we'll know about it. After multiple Ingress controllers, we'll go ahead and then install the AGIC Ingress controller on a new AKS cluster and application gateway with Helm CLI. With Helm chart, we are going to install it. And once we install it, we'll go ahead and then also implement a shared equal to true concept, which is sharing this application gateway with other resources on your Azure cloud in addition to AKS cluster related applications. So we are going to create 2 container instances, right? And then for those container instances also, we are going to share your application gateway. So when we access myACI app1.kubeoncloud.com via browser, so the the request comes to this application gateway, and from there it will go to myACI app1. Same happens for myACI app2. The request will go to myACI app2. In addition to that, if you access with the application gateway public IP with root context, then the request will come to app1. And here we are also going to learn about important concept called Azure Ingress Prohibited Targets CRUD. So that we are going to learn in detail. From there, we'll also go ahead and then implement Azure AGIC Watch Namespaces. So initially we'll test with creating a staging and production namespace and deploying our applications to staging and production. And both related Ingress service related changes will be applied on application gateway when we have the default option watch all namespaces. Later, we'll go ahead and then change our setting in our AGIC Ingress controller to watch only production namespace. And when we deploy both applications, only the Ingress service related to production namespace related changes will be applied on application gateway. So this way, we are going to implement all the 29 demos and sub demos inside them in detail in a very practical manner. So I'll see you in the next lecture. Until then, bye bye. Thank you.